Today we're going to be figuring out how to find the missing side length of figures that are similar to each other. In similar triangles, or really in any similar figures, the corresponding angles are congruent. That means the angles are the exact same, but the corresponding sides, those lengths are proportional. Because of this, you can use a proportion to solve for the missing side lengths in any similar figures, not just similar triangles. So here we have two similar triangles, and we know they're similar because they both have a 90-degree angle, they both have 53-degree angle. That means their third angle is also going to be congruent to each other, their third corresponding pair. So to set up a proportion, we need to set up what corresponds with what. Well, x corresponds with the 5. And I could set that up equal to the other corresponding pieces. 27 corresponds with the 9. There are actually 8 different ways to set up a proportion. As long as x and 9 are diagonal from each other, it's set up correctly. And to tell if you set it up or not, set it up the right way, the pieces need to correspond, but also the order matters. So here I started with my big triangle, x, and 5, my smaller triangle. So the big triangle's on top, the smaller's on the bottom. 27 is the bigger one on top, the smaller one on the bottom. So then we could solve by looking for a relationship between the numbers. 9 can go into 27 3 times, so I could do the same thing with my 5. Multiply by 3, and x is going to equal 15. And we could check and see if that makes sense. This smaller triangle is 1/3 of the size of the bigger triangle, or from the smaller triangle to the bigger triangle, it's times 3. Everything seems to match up. It's proportional. Okay, this next problem we have what's called a nested triangle, a triangle inside of another triangle. One strategy is to rewrite our triangle to separate them. So this is my smaller piece, the 6 and the 3. And then my outside triangle, the 6 and the 4 together make 10. So that represents the outside triangle. And then I have my x. So now that it's separated, I can see what matches what. My inside triangle is from A, it doesn't have my letters with it, but it's the 6 and the 3, so that's right here. And then my outside triangle is the whole shape, from A, B, C, back to A. Okay, so to set up my proportion, what matches with what? Again, there's 8 different ways to set up a proportion given these 4 numbers. And everything needs to match up correctly. So it doesn't matter what you start with first. I'm going to start with the 3. And the 3 matches the x. I could put it side by side. The 3 corresponds with the x, or I could put it up and down. The 3, since I started with the 3, the next one, 3 also goes with 6 because they're part of the same triangle. So 3 and 6 are part of the same triangle, and 6 corresponds with 10. This kind of matches the picture. I have the 3 and the 6, the x and the 10. But there's other ways to set up this proportion as well. Okay, then we look for a relationship in the numbers. And here the relationship to get from, I need to get 2x. And to get from 6 to 3, I just divide by 2. So 10, I'm going to divide that number by 2 to get the x value of 5. 5 and 10, a 3 and a 6. So we can see the numbers make sense. If this number was larger than the 10, it wouldn't make sense because the 6 is larger than the 3. Next problem, Sarah wants to use shadows to measure the height of the skull. Sarah is 5 feet tall and casts a shadow 3 feet long. If the skull casts a shadow that's 27 feet long, how tall is the skull? Well, for shadows, those create similar figures too. With problems like this, it's helpful to draw a picture. Here's Sarah, and she is 5 feet tall, so I'm going to label a 5 there. Then she has a shadow, which is 3 feet. Next, there's a skull, and we could try to draw a skull, or we could leave it as a line for the height, and that's fine. The shadow of the skull is 27 feet. We want to figure out how tall the skull is. It's almost like it creates similar triangles if we were to connect the edge of the shadow to the top, the height, the very top. So we have similar figures here, and we need to set up a proportion to match the corresponding pieces. 5 and 3 are part of the same. The 5 is the height, and the 3 is the shadow that goes with that height. Then 5 corresponds with X, and X's shadow is 27. This is another way of setting up the proportion. 5 and 3, X and 27. So I started with the height shadow. So it all matches up, and then it corresponds together too. Can X look for a relationship to get from the 3 to 27? That's times 9. So I could do the same thing to the 5 to get the X value, and X is going to equal 45. So that means the height of the skull is 45 feet tall. All right, let's try a couple more. On number 1, it says rectangle ABCD is similar to rectangle WXYZ. Find the length of WX. WX, right here, this is what we're looking for. WX are my first 2 letters, so that's going to match AB because they are also my first 2 letters. And visually that makes sense, the longer side and the longer side. But don't always trust the picture because sometimes the pictures can be misleading. But trust the similarity statements. So 12 and W correspond together. We need another pair of corresponding pieces, so we could use the 5. The 5 and the 12 are part of the same shape, so those also go together. And then 5 corresponds with the 4. They're the smaller piece. All right, set it up equal to each other. Here there's not an even relationship between the 5 and 12 or the 5 and 4, but to get from 5 to 4, we could divide to see the relationship, and we divide by 1.25. So I do the same thing to the 12, divide by 1.25. And we are allowed to use calculators that can help us to see how we get from one number to the next. So you can divide 12 divided by 1.25 in your calculator, and that missing side, the length of WX, is going to equal to 9.6. Connect the triangles below are similar, determining the missing side measure. Notice on this problem, there's not a similarity statement, but there are these little angle measurements to see what matches with what. Okay, I need to solve for X right here, and X corresponds with the 15. Then I need another pair of matching corresponding pieces. 4 is on the same shape as X, and it corresponds with the 6. Okay, so I have my proportion set up, and now I can look for a relationship between the numbers. 6 doesn't evenly go into 15, and 4 and 6 don't evenly go into each other, but I could also simplify this to help me. I could simplify the 4, 6 to become 2 over 3, 2/3, and then I could see a relationship here. Also, if you check the key, some of the proportions may be set up in a different way because there's several ways to set up the proportion as long as X and 6 are diagonal from each other, or we could have even used the numbers 8 and 12. So there's several ways to solve this problem. But to get from 3 to 15 times 5, so I could do 2 times 5 to get my X value of 10. X is 10. Okay, now each pair of polygons is similar and they have the congruent angle markings. Determine the missing side measures. So here X is between the one with the most marks and the one with 3 marks. So that's going to match our 18. X and 18 correspond together. Then we can pick any pair. It doesn't matter. We can pick 3, 6, or 9, and it's matching piece. I'm going to pick 3, the smaller of the sides. So that's on the same shape as the X, so it also goes with X, and that matches the 6. So here there's actually a couple relationships in this problem. I could multiply the 6 times 3 to get 18, or I could divide the 6 by 2 to get 3, but we need to solve for this X. So however we get to this X, we could get there from 3 or from the 18. To get from 6 to 18 times 3. So 3, we also multiply that by 3 to make an equivalent fraction. So X equals 9. Okay, next here, solve for the missing side length. X is going to correspond with, it's between the 1 angle mark and the 3 angle mark. So that actually corresponds with 8. It can get kind of confusing when the shapes are rotated like this. One strategy is to rewrite this shape so that they are facing the same way. That's another strategy. This is 8, this will be 14, and that'll be 20 with the, so for 8, that's going to be 1 mark, 2 marks, and 3 marks. Actually, I think I messed up right there. The angle marking. Let me correct that real quick. It gets confusing when the shapes are turned. You can correct it by turning it yourself. So I'm going to match it with these angles right here. 3, 1, and 2. There we go. I got it. So this is the 8, the 14, and the 20. So X corresponds to 8. And then we have 5. And the 5 is going to correspond with the 20. Because it's between the 2 and 3 mark angles. Here there's a relationship between 5 and 20. I need to get to my X. So to get from 20 to 5, divided by 4. Do the same thing to the 8. And then X equals 2. All right. Next we have a rectangular piece of plywood that has a length of 14 inches and a width of 19.6 inches. One strategy is to draw a picture for this. So 14 and 19.6. A similar rectangular piece of ceramic has a length of 2 inches. So length of 14, it's going to match where the 14 is. And we're looking for the width right there. So set up a proportion to solve. 19.6 and 14 are part of the same rectangle. And 19.6 corresponds with X, and X corresponds with 2. Then there's a relationship where we can multiply 2 times 7 to get 14, but we need to get to the X, so we're actually going to divide by 7. From 14 to 2, divide by 7. So divide 19.6 by 7, and that's going to give us an answer of 2.8. Last one. Actually, sorry, 2 more. On a sunny day, Jaleel cast a shadow of 11 feet, and the lamppost in the parking lot cast a shadow of 66 feet. If Jaleel is 6 feet tall, how tall is the lamppost? Draw a picture and solve. So here's Jay over here, and he cast a shadow of 11 feet. Then there's a lamppost. We could just draw a line, is fine. And it casts a shadow of 66 feet. And then he is 6 feet tall, and we want to know how tall the lamppost is. So now we have our similar figures right here, and we can set up a proportion to solve. 6 and 11 are part of the same. It's the height and the shadow, and 6 corresponds with the X, and 11 corresponds with the 66. And then to solve, we get to the x. We can multiply 11 times 6 to get 66. And we do the same thing to the 6. 6 times 6, x is going to equal 36. And last one, rectangle KLMN is similar to rectangle PQRS. Determine the missing side. So KL, which are my first two letters, is going to match PQ, my first two letters. So that's 5 and X are going to match. Also, the 4 and 3 will correspond as well. Here we need to get to our X value. To get from 4 to 5, we can multiply times 1.25. And you can figure that out by dividing that relationship. Do the same thing to the 3, multiply it times 1.25, and you're going to get an X value of 3.75. And that is how you find the missing side length in similar figures. Set up a proportion to solve.